So in this video, I will discuss about friction. Now, what is friction? When two bodies are in contact and have the tendency to move over one another, then resistance to the movement is set up. This resistance is called friction, or frictional force, or force of friction. Suppose you have a body. Uh, there is a body which is kept on this floor. This body is kept on this floor, and I am applying a force P. Then the body either will move in this direction or has the tendency to move in this direction. But there is a force which resists this movement and and will act in a direction in which the body tends to move. And this resisting force, this opposite force, is known as friction and is denoted by F, which is shown in this figure. Uh, in this figure, the W is the weight of the body, and R is the normal reaction, P is the applied force, and F is the friction, which will always act in a direction in which the body has a tendency to move or moves. So sigma, if you apply the conditions of uh, equilibrium on this body, then we get sigma h is equal to 0 or sigma fx is equal to 0. So P minus F is equal to 0. So finally we'll get P equal to F. Now if you apply sigma V equal to 0 or sigma Fy equal to 0, we'll get R equal to W. Now so these are the forces we'll get when a body is on a horizontal plane, and we'll get these two equations to solve any numerical. Now types of friction. Friction is of two types. One is called static friction, another is called dynamic or kinetic friction. Static friction. What is static friction? It is a friction experienced by a body when it is at rest. So suppose there is a body, and the body is is at rest at this on this floor, and suppose you are applying a force P. Now till that, the friction which acts on the body till that time at which the body is just at the point of movement. So that amount of friction up to which the body is at rest is known as static friction. As soon as the body starts moving, whatever friction acts on this body or acts on this body is known as dynamic friction. So what is dynamic friction then? It is a friction experienced by a body when it is in motion. So the figure shows that the friction are of two types. One is static, another is dynamic. Again, the dynamic friction is of two types. One is called sliding, another is called rolling. Now, sliding friction. Uh, when a body, when two bodies slides over one another, then whatever friction they experience are known as sliding friction. Now, when two bodies are rolling over one another, then whatever friction uh, acts on these bodies are known as rolling friction. Now, limiting friction. Now, what is the limiting friction? Uh, Suppose there is a body, and the force P is acting on this body. As I've already told, uh, whatever friction is acting on this body till the body is just at the point of movement, then that quantity of force is known as maximum static friction. And this maximum static friction is nothing but limiting friction. So in this figure, you can see the friction is shown on the y-axis and applied force is shown in the x-axis. Now, if you are applying force P on this body, then there will be friction. Friction will act on this body, and all of you know that the friction acts uh, between the surfaces of contact. This surface is the between the surface of contact of the floor and the body and the body. Now, if you are applying force P on the body, applying force on the body, then there will be friction. Now, as you go on increasing the force, the friction will go on increasing up to a certain point of force, up to a certain amount of force. Uh, the friction drops slightly, and the body starts moving. Now, till that time, at which the body just at the point of motion, just at the point of motion. Now, this friction, this maximum static friction, up to this point, the body is at rest. Now, if you increase the force slightly, if you increase the force slightly further, then the friction will drop and the body starts moving. Now, this friction, this friction, whatever you have, this friction is then dynamic friction. But this friction from this to this is the maximum static friction. And this maximum static friction is known as limiting friction. So, limiting friction is nothing but the maximum static friction or the friction which is acting on the body till the body is at rest. So, from this figure, you can easily say that the dynamic friction is always less than the static friction. Dynamic friction is always less than. So, dynamic friction UK is always less than mu s static friction. So, dynamic friction is always less than the static friction. Now, laws of friction. Here I will discuss the laws of static friction. Laws of static friction and the dynamic friction are one and the same thing. There is a difference of one or more points so that you can read from the books also. Now, what is that laws of static friction? Force of friction always acts in a direction opposite to that in which the body tends to move. As I have already shown that if this is the body, if this is the body is kept on this floor, and if the force is acting in this direction, and the body has a tendency to move in this direction, then the frictional force will act in the opposite direction. So this is point number one. Force of friction always acts in a direction opposite to that in which the body tends to move. Number two, the force of friction depends upon the nature of the surfaces in contact. So it depends upon the nature of surfaces in contact. Suppose the body is made up of wood and the floor is made up of masonry, then whatever friction is acting between wood and the masonry uh, is not the same if the if the if the floor is of let us say uh, of tiles, then the friction acting on this body will be different because the nature of surfaces are different. In the first case, uh, it is a friction between masonry and the wood, and in the second case, it is a friction between tiles and wood. So the force of friction F will be different, although the body is the same. So it depends upon the nature of surfaces in contact. Third is the force of friction is independent of the area of contact between the two surfaces. Suppose this is a body. Uh, so this is the body, and this body is kept on this floor. uh, let us say on this floor on this floor. Now the area of contact of this body with the floor is this. This is the area of contact. Now if I remove the body, and if I kept the body in this manner, the same body in this manner on the same floor, on the same floor, then the area of contact, is less. Now this is the area of contact with the floor. Here the area is more, here the area is less. But the friction acting on both this on the body are the same, because the nature of the material of the body and the floor are the same. There is no change in the nature of material. So the force of friction is independent of the area of contact between the two surfaces. The magnitude of the force of friction is exactly equal to the applied force. Magnitude of force of friction is exactly equal to the applied force. This if P is the applied force and F is the friction force, then if you apply sigma H is equal to 0, then definitely uh, frictional force is equal to the applied force. It will always be equal to the applied force. The magnitude of maximum static friction bears a constant ratio to the normal reaction. Normal reaction is R. F is the maximum static friction. So F upon R is a constant. And this constant is denoted by mu, which is known as coefficient of friction. Now from this we will get F is equal to mu into R. Now this you have to remember. So this is the force of friction is nothing but the product of coefficient of friction and the normal reaction. Now what is coefficient of friction? So coefficient of friction, it is the ratio of limiting friction to the normal reaction. It is denoted by mu and it has no unit. So mu is F upon R. It is the ratio of limiting friction and the normal reaction. Angle of friction, it is denoted by phi. It is the angle between the resultant of it is the angle between the resultant of normal reaction and frictional force. This is the resultant S of normal reaction and the friction force. So the angle made by the resultant with the normal reaction is called angle of friction. So angle made by this resultant of F and R with R is known as angle of friction. Now tan phi, now if you complete this, if you draw a perpendicular from here, so this is a right angle triangle. Now from this right angle triangle, you can see that tan phi is this upon this. This is F and this is R. So tan phi is F upon R, and F upon R is mu. So tan phi is always equal to mu, or you can say mu is equal to tan phi. So in some numerical mu will be given, in some numerical phi will be given. So if phi is given, you can easily find out mu. Angle of repose. It is the maximum angle of inclination of the plane at which a body remains in equilibrium under the action of friction only. Suppose this is the inclined plane. Now suppose this is the inclined plane on which this body is kept. Now if the body is in equilibrium, is in equilibrium due to friction only, the body is at rest due to friction only, then this angle of inclination of this plane is known as angle of repose. So it is the maximum angle of inclination of the plane at which the body remains in equilibrium under the action of friction only. Now if you increase this inclination, if you increase this, let it be theta 1. Uh, and if due to this increase in inclination, if the body starts moving in this direction, then this theta 1 is not angle of repose. So angle of repose is the maximum angle of inclination of the plane at which the body remains in equilibrium under the action of friction only. Now, forces acting on a body when kept in an inclined plane. What are the forces acting on a body when it is kept in an inclined plane? Now, this is the inclined plane. Uh, the angle between the horizontal and the inclined plane is alpha. Now, the forces are, this is the applied force, this is the normal reaction normal to the inclined plane, and there is a weight of the body acting vertically downward, and F is the frictional force. Now, only thing you have to remember, you have to see in which direction the body is moving. If the force is acting in the direction and the body is also moving upward, then the frictional force will act downward. And if force is acting upward but the body is moving downward, then again frictional force will act upward. So that you have to keep in mind while showing the direction of friction. So these are the forces which will act on a body when kept on an inclined plane. What are the forces? One is the applied force. Next is the normal reaction. Then the frictional force, the weight of the body. There will be no other force acting on a body which is kept on an inclined plane. Now, equilibrium of body on an inclined plane. We'll discuss the equilibrium of the body on an inclined plane. Now, the condition is force acting along the inclined plane and the body has the tendency to move upward. The force is acting along the inclined plane but the body has a tendency to move upward. Body has a tendency to move upward. That means in this direction. So that's why the frictional force is acting downward. Now, what we'll do, we'll resolve the weight of the body into two directions, W cos alpha and W sin alpha, that is perpendicular to the plane and parallel to the inclined plane. Now, if this angle is alpha, we know that this angle will be alpha. So that's why this is W cos alpha and this is W sin alpha when you are resolving this W perpendicular to the inclined plane and parallel to the inclined plane. Now, if you apply conditions of equilibrium on this body, then what we'll get? We'll get sigma v equal to 0, and sigma v is uh, means r equal to w cos alpha. So you get r equal to w cos alpha. Now, if you apply sigma h is equal to 0, then we'll get p is equal to f plus w sin alpha. So p is equal to f plus w sin alpha. Now, what is f? F is mu into r. So mu r plus w sin alpha is equal to p. And what is r? R is w cos alpha. So you put the value of r here. So mu w cos alpha plus w sin alpha equal to p. Therefore, p is equal to w mu cos alpha plus sin alpha. Now the force is acting along the inclined plane and the body has the tendency to move downward. In the previous case, the body was moving upward. That's why F was acting downward. Here the body is moving downward. That's why the frictional force will be upward. Rest of the forces will be the same. So again, we will apply sigma V and sigma H. Now if you apply sigma V, you will get R equal to W cos alpha. If you apply sigma H is equal to 0, we will get P plus F equal to W sin alpha. Again, you put what is F? F is mu into R. So P equal to W sin alpha minus mu R. You put the value of R. So mu sin alpha minus mu W cos alpha. So finally, you will get W sin alpha minus mu cos alpha. Now, force acting horizontally and the body has the tendency to move downward. Here the force is acting horizontally. It is not acting parallel to the inclined plane, but it is acting horizontally. So if it is acting horizontally, then you have to resolve the forces perpendicular to the plane and parallel to the inclined plane. Now if this angle is alpha, then this angle will be alpha. And you know this angle is alpha. You already know this. Now again we'll apply conditions of equilibrium. So sigma v equal to 0. So what we'll get? We'll get R equal to W cos alpha plus P sin alpha. R equal to P sin alpha plus W cos alpha. Now if you apply sigma h is equal to 0, we'll get P cos alpha plus F equal to W sin alpha. So P cos alpha plus F equal to W sin alpha. Now P cos alpha plus what is F? F is mu into R. So W is equal to W sin alpha. Now P cos alpha plus mu. What is R? R is P sin alpha plus W cos alpha equal to W sin alpha. Now if you simplify, we'll get P equal to W sin alpha minus mu cos alpha upon cos alpha plus mu sin alpha. Similarly, you can easily find the expression for P when the forces are acting horizontally and the body has the tendency to move upward. So you do it uh, as a practice by your own. So thank you very much.